All right, hey everybody, we're moving on to our third standard, that is to determine the solution set to radicals and nth root equations. So we're going to be working with equations that involve a radical, and that could be a square root, or it could be an nth root, like a third root or a fourth root or something. And we're going to go ahead and get going on those. This is video 931, that's our third standard, and we're working on solving. Let's go ahead. So to start with this, remember with solving we always want to talk about the inverse operations, like what undoes what has happened to x. And if I have a square root in an equation, if I wanted to break x out of this square root, I would want to square both sides. You see, the inverse of a radical is an exponent. So that means that if I have a cube root that I'm trying to work with, if I have a cube root, then I would want to cube both sides in order to break the radical. So the inverse of our radicals are the exponents that match the index. Let's go through these examples. So our first example is x equals the square root of 3x plus 18. So before I'm able to get x by itself or use any other method, I have to get rid of this radical because there's an x trapped underneath of it. So I will square both sides because that will eliminate the radical. Oops. That will eliminate the radical from the right-hand side. So that does leave me with x squared equals 3x plus 18. And I recognize now that I have a quadratic, so I'd want to move all of the x's to one side, including the 18, set it equal to 0, and I can use one of the methods that I know to solve a quadratic equation. I can use inverse operations, I can use factoring with the zero product property, or I could use the quadratic formula. I'm going to go ahead and factor this one because I know that 6 times 3 makes 18, so that'd be x minus 6 and x plus 3. That also gives me the negative 3x that I need. So x equals positive 6 and x equals negative 3. Now I'm not done there because if I go back to the very beginning of this, I would have to check my work. So to check my work on using x equals 6, I would have 6 equals the square root of 3 times 6 plus 18, which means 6 equals the square root of 18 plus 18, which is 36. So this works. Let's go to the other side. Negative 3 equals the square root of 3 times negative 3 plus 18. That is, negative 3 equals the square root of negative 9 plus 18, or the square root of 9. You see, but this doesn't work because I cannot have a square root equal to a negative number. So negative 3 is an extraneous solution, and my only answer is x equals positive 6. Let's try another example. For this one, while they look very similar, I end up with two terms on the outside, whereas on the first example I only had one term on the outside. So we use a slightly different strategy just to get started. Then we'll proceed the same way. That is that I want the radical to be by itself. So I'm going to add the x to the other side and subtract the 4 to the other side. That is moving these two terms that way. Well, now I'm ready to square both sides. But when I square this side, I'm going to grab a different color so you can see what I'm doing on the second step. And that is to square this, but I have to square the entire side, which leaves me over here with just a 2x because my radical is canceled by the power. And on this side, I have x minus 4 times x minus 4. Don't try to go too fast and just square the parts inside of the parentheses. You actually have to square the factor of x minus 4, leaving me with x squared minus 8x plus 16. Well, now I'm looking at a quadratic that I want to set equal to 0. So I'm going to move that 2x over, and I'm going to be able to solve this. I'm again going to factor to x minus 8 and x minus 2. That leaves me with a negative 2x but a positive 16. So x equals 8 and x equals 2. I certainly do have to check again to make sure that I don't have an extraneous solution. So here's my checking step. I'm going to have the square root of 2 times 8 minus 8 plus 4, and I want to know if that equals 0. That is the square root of 16 minus 4. Does that equal 0? And it sure does. For the 2, I have the square root of 2 times 2 minus 2 plus 4, and does that equal 0? That is the square root of 4 minus 2 plus 4 equals 0. Well, the square root of 4 is 2 minus 2 gives me 0 plus 4 equals 4. So once again, we had an extraneous solution, and the only answer is x equals 8. You can see how important it is to be checking your answers. Let's see what else we've got. So in this case, it doesn't appear that I have a radical equation. It appears like I've got an exponent equation. But remember that this is the same as saying the cube root of 3x plus 7 will equal the cube root of 4x plus 2. So in order to eliminate the radicals, I'm going to cube both sides. So in cubing both sides, it doesn't really affect anything except that it cancels the operations, leaving me 3x plus 7 will equal 4x plus 2. And then I'm ready to solve. That would leave me with x equals 5. I should check my work. 3 times 5 plus 7 is that, and the cube root of that, or the 1/3 power. 4 times 5 plus 2 to the 1/3 power. This is 15 plus 7, or 22 to the 1/3 power, which simplifies on the other side the same way, 22 to the 1/3 power. So I don't have to evaluate that. Both sides are the same. That's what an equal sign tells us. So we got it. All right, our last example here. In this case, I have a 4th root, so in order to cancel a 4th root, I have to use a 4th degree. So I'm going to raise both sides to the power of 4. So I have x squared plus 6x, and now that's going to equal 2 to the 4th power, which is 16. I'm left with a quadratic, which you're going to find quite frequently. Minus 16 equals 0, and I can choose to factor it or use the quadratic formula. So I have x plus 8, and I have x minus 2, and I get x equals negative 8 and x equals positive 2. So I'm going to check my work to make sure that it pans out for me. So that is the 4th root of negative 8 being squared, don't forget parentheses, plus 6 times negative 8, and I want to know if that equals 2. And on the other side of that, I'll try the 4th root of 2 squared plus 6 times 2. Does that equal 2? So we'll just simplify. This gives me 64, and that should be a negative 48, so minus 48, which is 16. So the 4th root of 16 is 2, and the negative 8 checks out. On the other side, I should have the 4th root, I should keep that there, sorry, the 4th root of 4 plus 12, which is the 4th root of 16, which also equals 2, of course, so both of these answers do check out. All right, great job with these. We'll just work on more of them when we're together.